Hello everyone, hope you are doing well. I am your instructor Akshay Parmar, Assistant Professor at LJ Institute of Engineering and Technology in IT-ICT department. So far we have seen that microcontrollers, right? And in that we have seen that Arduino Uno, right? So in this today's session we are going to see another type of microcontroller, and that is Raspberry Pi, right? So before going down into the Raspberry Pi, what is how it is using and all that things, let's see the basic behind what is the purpose behind that developing in Raspberry Pi, and in the initial days where does this Raspberry Pi is used, right? And after that we will see the different application of the Raspberry Pi, and we will see the one example in that, and after that we will see that how we can develop and one simple application with the help of the Raspberry Pi, right? So let's begin with the origin of the Raspberry Pi, right? So yes, the Raspberry Pi was developed by a charity organization founded in 2009 in United Kingdom, right? They are the responsible for developing a Raspberry Pi, right? That Raspberry Pi is supported by a University of Cambridge Computer Laboratory and the Broadcom, right? It promotes the study of computer programming in the school from the KG to the 12th standard, and in the they are used in the developing countries, right? For the more information you can visit its official website, that is in www.raspberrypi.org, right? Or in that, in the about section you can see all the basic details about the Raspberry Pi, right? In the about section you can see all that basic detail about the Raspberry Pi, right? After that, the Raspberry Pi is originally designed for an education purpose only, right? For the schools in the developing country, or from the senior KG to the 12th standard, that Raspberry Pi is developed for affordable computer, right? It is created a low cost device that would improve the programming skills and hardware understanding at the pre-university levels, right? So remember that it is originally designed for an educational purpose, right? It is create a low cost device that will improve the programming skills and hardware understanding at the pre-university level, right? Thanks to its small size, accessible, uh, thanks to its small size and accessible prices. Now it is used in thousands of the various different ways, right? So Raspberry Pi, right? So initially it was developed for an educational purpose, and now it is widely used in the IoT systems, right? So your one question arises, right? Sir, from where that Raspberry Pi name comes from, right? So yes, where does the Raspberry Pi names come from, right? So many computer companies are named after the fruits. For an example, Apple, BlackBerry, Tengen Computer Systems, Apricot Computers, Ecom Computers, and all that things, right? So following this particular trend, the Raspberry Pi is come under that, right? So you can say that, sir, Raspberry is there, right? So what do you mean by Pi in Raspberry Pi, right? So Pi means Python interpreter, right? So Raspberry is there as a name of fruit, right? Which the company has followed that particular trend to name their company after that fruits, right? And what does this particular Pi means? Pi means Python interpreter, right? It is used for learn programming using easy programming languages, Python, right? It is easier than C and C++, right? So let's see the evolution of Raspberry Pi, right? So there are so many generations are passing through from the initial days, right? So in the initial days of the February 2012, right, its first version, the model B, was introduced, right? So it is in first generation models, right? After that the model A is there, model B plus is there, and model A plus is there, right? So initially from the 2012 to 2015 14, from the initial the February 12 to the November 14, that is evaluated itself from the basic model B to model A plus, right? After that another generations and the model of the Raspberry Pi, right? After that the second generation is there, that is a model B, which is introduced in 2015, right? It is cost around $35, and it has 4 USB ports, right? And which is having a micro SD card slots also. After that the model 0 is introduced in the November 15, which is cost only $5, right? Which is having one micro USB port and one micro SD card slots there. After that the third version of the model B is introduced in the February 16, right? Which is cost around $35, which is having 4 USB ports, micro USB card slots, and here the new features are introduced, the Wi-Fi as well as the Bluetooth connectivity. Like detailed information for all that models and accessories can be found at raspberrypi.org, and in that particular official website, in the product section you can find out all that basics details about all these particular models, right? So you can visit that website and you can get yourself detail with the particular models, right? So Raspberry Pi, right? So basic of the Raspberry Pi. Let's see which are the function and which are the component of the Raspberry Pi. The power supply is a foremost fundamental thing for for each and every electronic device, right? So for the power supply, we are having a micro USB slot which is embedded in the Raspberry Pi, right? So with the help of that micro USB card slot, we can give the power to the Raspberry Pi, right? After that, for the storing purpose, we are having a micro SD card slot, right? So by which we can connect a micro SD card with the Raspberry Pi, right? After that, the GPIO pins are there. After that, we need several input and output devices, right? For an example, keyboard, mouse, and all that things, right? So with the help of that USB slots, we can connect that USB keyboard, USB mouse, and all kind of input and output devices. Display also we can connect with the help of the USB slot as well as with the help of the HDMI slot, right? For the display purpose, we can connect with the HDMI slot, right? After that, for the connectivity with the internet or for the network establishment, we are having a LAN cable, LAN connectivity with the Raspberry Pi also, right? For the monitoring purpose, we are having an HDMI slot, right? So with the help of that, we can connect and see computer monitor with the Raspberry Pi, right? So that are the basic fundamental component of the Raspberry Pi, right? So by which we can connect the several input and output devices with the Raspberry Pi, right? So let's see the component of the Raspberry Pi 3, right? So in that the CPU, right? So let's see the component of the Raspberry Pi 3, right? So in that, let's begin with its brain, the CPU, right? Which is having a quad core 64-bit ARM Cortex CPU, right? Which is having an FI3 clocked at the 1.2 gigahertz, right? So you can imagine that small device is having a 1.2 gigahertz clock speed, right? After that, the GPU is there, which is having a 400 millihertz video core of for multimedia, right? So that is a GPU configuration of the Raspberry Pi 3. After that, it is having a memory, right? 1 GB RAM is there in the Raspberry Pi 3. After that, we are having a 4 USB slots, right? With the help of that, we can connect USB monitor, USB keyboard, USB mouse, and all kind of devices, right? After that, for the video output, we are having an HDMI slot, right? Which is composite video of the PAL and NTS with the help of 3.5 mm jack. After that, for the networking purpose, we are having 10/100 Mbps Ethernet cable and 102.11 and wireless LAN connectivity. For the peripheral devices, we are having a 17 GPIO pins, right? GPIO pulse specific function and head ID buses, right? We are having a Bluetooth 4.1 with it is embedded in the Raspberry Pi 3. For the power sources, we are having, as we have discussed, for the power sources we are having a micro USB slot, right? So we are getting a 5-volt power supply with the help of micro USB or GPIO headers. So its size, let's discuss its size, right? Its width its width is 85.60 mm and its height is 56.5 mm, right? So 85.60 cross 56.5 mm is its size, right? And it is weight around 45 grams, or it is nearer to 1.6 oz, right? So that is a basic component. That are the basic component of Raspberry Pi 3, right? After that, let's see which are the operating system which we can embed it on the Raspberry Pi. There are the several options available which we can deploy on the Raspberry Pi, right? So Raspberry Pi is full blown computer, right? So it is obviously it is having an operating system, right? So operating system, the Raspberry Pi Foundation recommends the Raspbian operating system for Raspberry Pi, right? It is optimized for RPIs, right? Other operating system you can install on the Raspberry Pis are Ubuntu Mat, Snappy Ubuntu Core, Windows 10, IoT Cores, OSMC, RISC OS, Fedora Remix, CentOS, and Kali Linux. There are the several options, there are the several options whose OS we can install or we can deploy on the Raspberry Pi 3, right? So the Raspberry Pi Foundation is recommending us an Raspbian OS for the Raspberry Pi, right? So let's see some application of the Raspberry Pi 3, right? Epiphany, right? A standard web browser for the Raspbian, right? Is already available. Epiphany is a standard web browser for the Raspbian, right? After that, the GUI based file manager is there in the Raspberry Pi 3, right? The file manager is there. After that, for the terminal application, we are having an LX terminal, right? After that, the mathematical application is there, right? A specialized mathematical application that deals with the calculation, graph, and several kind of mathematical operation is performed with the help of Mathematica application, right? After that, for the educational application designed to make a music and learn programming easy, we are having a Sonic Pi application which is embedded in the Raspberry Pi and its OS is Raspbian. After that, the game is also there, right, in the Raspberry Pi, and if we are installing the Raspbian OS, then there is a one game there, right? There is a Minecraft Pi, right? That is a very popular 3D graphic game there, right? After that, that about the basic application we are getting in the basic Raspbian OS, right? After that, if we want to code with the Raspberry Pi, then we can program that Raspberry Pi with the help of several programming language and several programming platforms, right? It's one of the option is Scratch, right? So what do you mean by that particular Scratch, right? It's a free visual programming language, right? It is having a drag and drop interface like MIT App Inventor and kind of thing, right? The one of the best way to introduce a young people into the joy of programming, we can introduce a Scratch to them, right? With the help of the Scratch, any newbie or any high school grade students, they can also get their hand dirty with the programming, right? Also, a user can create computer games, interactive stories, and animation using some programming techniques without actually having to write the code, right? So for getting more information about the Scratch, you can visit its official website, that is an http that is an scratch.mit.edu, right? So that is about an Scratch programming, right? The another thing by which we can program the Raspberry Pi is Python, right? The Raspberry Pi, the name itself, the Pi is there for Python interpreter, right? The Python is a wonderful and a powerful programming language, right? It is easy to use and learn. The Python syntax are very clean with the emphasis on readability and the uses standard English keyword, right? So the Python is really basic programming language by which you can code into the Raspberry Pi, right? So let's take an example. If you are buying and one fresh Raspberry Pi, right? So how can you deal with that, right? So for that, fundamentally what you need to do, so for that you need to install one OS into the Raspberry Pi, right? So let's see, if we want to install an OS into the Raspberry Pi, right? What is Raspberry Pi, right? Raspberry Pi is a fully blown computer, right? So for the installing that operating system, we are using an Raspbian OS for that, right? So how we can install an Raspbian into the Raspberry Pi? There are the two methods there. By the use of noobs and with the use of noob lights, and we can download only the Raspbian image file with that, right? So there are the three methods by which we can install the Raspbian OS into that. What is noobs, first of all, right? Noobs is an easy operating system installer which contains Raspbian. For the OS and the noobs download file, you can visit the Raspberry Pi org, and in the software section you can find both the noobs and the OS of, right? The Raspbian will be stored into the micro SD card, right? After storing that OS into the micro SD card, you can connect that micro SD card to the SD card reader, and after that you can connect that micro SD card into the Raspberry Pi, right? So micro SD card cannot be connected to the PC without the micro SD card, right? So for that You install that particular micro SD card into the micro SD connector, and after that connect that micro SD card connector with the Raspberry Pi, right? So for the installing purpose, right? So for the installing the Raspberry Pi, we are having in two methods, with the use of the noobs and with the use of noobs, right? Noobs Lite, right? So for if we are selecting with the help of the noobs, right? So for the noobs, we are unzipping and copy that particular Raspbian OS into the micro SD card, and after with the help of that, we are installing that Raspbian OS using the use of noobs into the Raspberry Pi, right? If we are not using that noobs, then first of all unzip and copy that OS into the micro SD card, right? And after that, boot that RPIs, right? There is a no installation there, right? It needs to set up at the partition, right? So by that you can install that Raspberry OS into the Raspberry Pi, right? So there are several components which is already there into the Raspberry Pi. With the help of the USB slots, you can connect keyboard and mouse. For the projection purpose, you can have an HDMI cable. For the power supply, we are having a micro USB slots, right, by which we are giving a 5-volt voltage to the Raspberry Pi, right? For the storage and all kind of purpose, we are having a micro SD card slots there, right? That is the basic component of the Raspberry Pi, right? After that, whenever we are booting a GUI, right, Raspberry Pi is starting its initializing states, right? After that, the Raspberry Pi is getting installed, right? And at the end, after installing the process, the Raspberry Pi will install into your system, right? Let's connect with the help of the Wi-Fi, right? Connecting via Wi-Fi. A Raspberry Pi is having a built-in Wi-Fi connectivity, right? In the earlier version of the Raspberry Pi, there is a need, if you want to connect on the Wi-Fi, then you need a Wi-Fi dongle. But from the Raspberry Pi of Pi 3 and above versions, there is having an inbuilt Wi-Fi connectivity, right? So you don't need to have any additional Wi-Fi dongles, right? Some Wi-Fi dongles are simple plug and play devices, right? Other require specific drivers and may not be compatible with the all of the devices, right? It is reading the device manufacturer's documents and all kind of thing, right? So with the help of that, we can connect the Wi-Fi with the Raspberry Pi, right? Nowadays, all the models are having a pre-built or inbuilt Wi-Fi modules there, right? After that, connecting with the help of the Ethernet. Raspberry Pi has an Ethernet port beside that USB slot, right? You can observe that thing. You can connect to the network using that Ethernet cable. With the help of the router, access point or switch, you can connect them with the Raspberry Pi with the help of Ethernet cable, right? That's about the basics of the Raspberry Pi, right? Let's see one application, how it's built, right? With the help of the Raspberry Pi, we have taken in one basic application of blinking LED, right? So for that, what are the components we require, right? So for that, the necessary component to blink LED with the help of the Raspberry Pi is having a Raspberry Pi board itself, one breadboard, one red LED, or you can select any colors LED, right? After that, one resistor and the jumper cable be required, right? So with the help of this basic component, we can turn on and turn off LED with the help of Raspberry Pi. Let's see how to interface that connectors and Raspberry Pi, right? For cathode of the LED is connected to the ground pin of the Raspberry Pi, and the anode of the LED is connected at the ballast resistor, right? Because with the help of that resistor, we can reduce that given power to the LED, and we can save the LED's lifespan, right? So we are connecting the cathode of the LED with the ground pin, and we are connecting that ballast resistor with the anode of the LED light, right? And after that, the resistors is connected to the power voltage to the Raspberry Pi, right? Let's see the blinking. The anode of the LED is connected to the ballast resistor, right? And another end of the ballast resistor is connected with the pin GPIO 17, right? So with the help of that, it is getting its power, right? So there are the two pins by which we are connecting the LED and the resistor, right? So let's see some basic coding by which we are turning on and turning off the LED light, right? So for that, the first line is import RPI, GPIO and GPO, right? So there are the import of the Python GPIO modules, right? So with the help of that, we are importing that Python GPIO modules, right? After that, there is a one line GPIO.output, and in that we are specifying the pin, and in that the GPIO pin we are getting an high, right? So by selecting that high pin, right, we are turning on that LED, right? After turning on that LED, we are putting them for it some time delay for that, right? So we are keeping a time slip of 1 second, right, which will be given and delay of 1 second, right? After that, we have to lower down that signals, right? So with the help of GPI.output pin, and that GPI.low, with the help of that, we are turning off that LED light, right? After that, the GPIO.set mode, GPIO.BCM, and GPIO.setup, in that 17 number pin is there, right? The GPIO.out, right? So with the help of that, we are selecting that GPIO pin number 17 as an output pin, right? So with the help of that, GPIO output pin, we are given that high voltage for the 1 second. After giving that high voltage for the 1 second, we are taken back that voltage. We are given the low voltage to that GPIO pin number 17, so that power will not pass to that from that resistor, and that LED light, so the LED light will not blink, right? After, whenever we are giving a high voltage to GPIO pin number 17, right, then the LED light will getting its power and it will be glowing, right? After glowing for the 1 second, that power is taken back, and again that GPIO pin number 7 is getting low, right? So the LED light will not getting any power, so it will turning off itself, right? So that is an basic output of blinking an LED light with the help of Raspberry Pi, right? So that's about an basics of the Raspberry Pi. What is the need of initialization phase of the Raspberry Pi? Where does it use? And after that, we have seen one real life example or one real life application of Raspberry Pi, right? So that's all about today's session. Thank you for the watching.